Hello everyone who is watching the Black Box Silent channel, where we analyze outstanding events, not only from a technical perspective, but also from the perspective of responsibility, people, and systems. In today's video, we will look back at the rare but also alarming incident related to Air India flight AI171. A seemingly normal flight ended in a catastrophic crash, killing a total of 260 people, including 241 on board and 19 on the ground, with only one British passenger surviving. Dozens of people on the ground were injured. Why could a Boeing 787 Dreamliner, the most modern aircraft in the world, have an accident when landing in not too harsh conditions? The role of data recorders, abnormalities in the flight path, and the story of the response capacity of the operating team all will be analyzed in the most logical, easy to understand, and realistic way. If you work in engineering, aviation, systems operations, or simply want to understand how an accident happens and learn from it, stay until the end of the video. Why did you cut off the fuel? I didn't cut it. Just two short sentences heard in the cockpit, recorded from the black box, have sent shockwaves through the aviation industry. It was not just a conversation, but the first glimmer of light behind the tragedy of Air India flight AI171 on June 12th. The official preliminary report has just been released, and it is this conversation that has revealed a shocking truth. This was no longer a simple accident. It raises the burning question: was there human error, intentional behavior, or just a cruel fate that no one could have prevented? In this video, we take a deep dive into the details and moments that happened in the cockpit of the ill-fated Boeing 787. The crash site left behind several important clues. The door to the APU, the plane's auxiliary power unit, was found open. This suggests that the crew may have attempted to activate the APU in an emergency when both engines were showing signs of losing thrust. This is a maneuver that would only happen in the worst-case scenario, when everything else had failed. Inside the cockpit, the brake lever was located at position 5, exactly where the remaining brake lever on the broken wing was. This showed that the flight control system was still operating normally at the last moment. Meanwhile, the landing gear lever was still in the down position, meaning that the crew had not had time to retract the landing gear after takeoff, an unusual detail that could reflect the chaotic situation just minutes after leaving the runway. What is even more remarkable is that the two fuel control switches were still in the run position, meaning fuel was still being supplied to the engine. This information was immediately cross-compared with data from the black box to determine the time and technical developments leading to the fateful crash. The engine's thrust lever was found in the idle position, no load, at the scene. But the black box data showed that, until the last moment, the throttle lever was still in the forward thrust mode. This proves that no one released the throttle. It was not an intentional maneuver, but the terrible collision itself had pulled it back to that position. The AI171 flight crew consisted of a total of 10 members, 2 pilots and 8 flight attendants, of which there were only 2 people in the cockpit, the only 2 people facing the fateful final minutes. The pilot was Captain Sumit Sapawal, 56 years old, one of Air India's veteran pilots. He has more than 1,500 accumulated flight hours, including 80 hours directly controlling the Boeing 787 Dreamliner. Having flown many wide-body aircraft such as B777, B747, but with Dreamliner, he is an expert. Next to him is First Officer Clive Kunda, 32 years old, a talented young generation rising in the Indian aviation industry. Despite his young age, Neeraj has over 300 flight hours, of which 1,150 hours are combat experience on the Boeing 787. He graduated with honors from the Indira Gandhi Aviation Academy and is considered to have the ability to react quickly in emergency situations. There was no backup pilot on the long transcontinental journey, no flight engineers or independent observers. In the moment of life and death, every decision, every operation, just those two men. Both were confirmed to have completed the full pre-flight check at London Heathrow, including weather assessments, engineering reports, and refueling. Both black boxes, the flight data recorder and voice recorder, were recovered intact and successfully decoded in New Delhi. The data from them was the final piece in a tragic jigsaw puzzle. The analysis was carried out in coordination with many parties: Boeing, General Electric, the engine manufacturer, and the US National Transportation Safety Board. What they found, from the data, from the scene, from the words trapped in the black boxes, painted a stark and unpalatable picture. But it was the truth, and it needed to be heard. The Boeing 787, one of the world's most modern and safest aircraft, is equipped with two integrated data recorders located in the nose and tail of the plane. Both black boxes were recovered intact after the crash and contain complete flight data and cockpit voice. From these recordings, investigators have reconstructed almost the entire final journey of the fateful flight. After a thorough analysis of the crash site and the collected data, they came to a haunting and consistent conclusion. There was no mechanical failure, no design defect, and no signs of any abnormality in the engines. The plane, as well as both General Electric engines, had been operating normally until the very end. And then, everything collapsed because of a single detail. Two fuel control switches, which play a vital role in maintaining engine operation, were pushed to the cutoff position. That means the fuel was completely cut off, causing both engines to shut down immediately after the plane left the ground. What has brought the investigation to a standstill is no one understands why and who did it. Up to this point, no official answer has been given, and perhaps the answer will be buried forever with that fateful moment. Flight AI171 was scheduled to take off from India to Gatwick Airport, England, with 230 passengers and nearly 54 tons of fuel, close to the allowable takeoff weight limit, but still within the safety zone. According to procedure, the co-pilot flies the plane during the takeoff phase, while the captain monitors and controls the system. The key speed marks were set. V1 was 153 knots. The unstoppable speed, rotate, was 155. The point at which the aircraft would raise its nose, and V2 was 162, the minimum speed required to ensure safe climbing. The weather that morning was quite hot, 36 to 37 degrees C, but still within the safe operating limits. The wind was light and steady, with no adverse effects. The engines started steadily, and the taxi to the runway went smoothly. At 13:07:37 local time, the aircraft began to taxi for takeoff. At 13:08:33, the speed reached V1 unstoppable. 4 seconds later, the aircraft lifted off the ground. The speed continued to increase, reaching 180 knots a few seconds later. Until then, everything was perfect, no signs of anything unusual. But then, the unthinkable happened. Both fuel switches were flipped to the off position just 1 second apart. Immediately, the engine's N1 and N2 readings plummeted, signaling a complete loss of thrust. The cockpit descended into chaos. The black box recorded a chilling exchange. One pilot shouted, "Why did you cut the fuel?" The other replied, "I didn't cut it." In a split second, an aircraft that was on a safe ascent to altitude became an uncontrolled mass of metal in mid-air, without engines and without lift. To understand why this incident shook the entire aviation industry, we need to look deep into the Boeing 787's state-of-the-art control system. An aircraft is more than just a hunk of flying metal. It is a machine so complex that every operation is designed to prevent errors, especially with the fuel system. Just behind the two throttles, left and right, were two fuel control switches, each shielded by a metal cover to prevent accidental operation. To turn off the fuel, the pilot had to perform at least 3 consecutive steps, with both hands, overcoming enough mechanical resistance to confirm this could not have happened by accident. It could only have happened on purpose. And that was the suffocating point of the whole disaster. As the plane soared into the sky, the captain was busy adjusting the thrust, and the first officer was gripping the control stick to hold the nose of the plane. During the entire takeoff procedure, there was not a single moment when both pilots had a free hand to turn off the two fuel switches on either side of the cockpit. So who did it? Or what actually happened in that cockpit? Because less than a few seconds after leaving the ground, both engines lost thrust almost simultaneously. Something that was not in any emergency scenario. No airport trained for that. No simulation allowed it to happen. And then, in the final recording, a chilling line rang out amid the constant sirens, a whisper of fate. "Why did you cut the fuel?" "I didn't." Just 2 sentences, in the middle of a life or death moment. But they were 2 questions that no one could answer. They were the haunting obsession that weighed heavily on all investigators, engineers, and even the passengers' relatives. And until today, that silence no one has been able to break. A big question still hangs in the air, unanswered. Who said, "Why did you cut the fuel?" And who said, "I didn't"? The preliminary report did not clarify, and this is the key point that is still waiting to be answered in the upcoming detailed report. What has drawn experts' attention, however, is a previously issued safety directive that concerns the mechanical design of the fuel switch on the Boeing 787, a design that is almost identical to the switch that has been questioned on the Boeing 737, a model that has had many problems in the past. Air India had received a recommendation to inspect and maintain the system across its fleet. But instead of doing so, the airline ignored it because it was a safety bulletin, a non-binding advisory. And from there, an engineering hypothesis began to form. Could someone in the cockpit have accidentally touched the switch area while the plane was shaking slightly, especially if the metal shields were worn or no longer functioning as designed? The possibility of accidentally activating the fuel switch cannot be completely ruled out. The fuel control switch area is located just behind the thrust lever, a location that is easily accessible, especially when the pilot is holding the throttle steady during takeoff. At 13:08:05, the Boeing 787 gained enough speed to leave the runway, the nose of the plane slowly rising. By 13:08:42, the plane had begun climbing at around 330 km, as per normal takeoff procedures. But just 36 seconds later, all the main electrical systems suddenly went offline. Data from the black box stopped completely, as if the plane had fallen into a dead space. When the fuel supply was cut off, the emergency air turbine, a small fan-like device called the RAT, deployed. It was the last device that could provide emergency power and hydraulic pressure to the vital systems. The RAT worked as designed, but by that time, the plane had begun to lose altitude rapidly and dangerously. Survey data confirmed that the RAT had deployed correctly. The sequence of events that followed made it clear. In the cockpit, someone was desperately trying to restart the engines. 13:08:47 RAT starts. 13:08:52 engine number 1 fuel switch is turned back on. 13:08:54 APU door opens. 13:08:56 engine number 2 fuel switch is turned to start. These continuous actions make it clear. Someone in the cockpit is making a desperate effort to restart the engine. The digital control system immediately begins the restart sequence. Engine number 1 shows signs of recovery. The core shaft stops and then starts rotating again. But engine number 2 cannot reverse the deceleration. The system continues to pump fuel, but engine number 2 is too late. Everything happens too fast. The entire restart process took time, but from the moment of loss of thrust to impact, less than 30 seconds had elapsed. That was not enough time for any of the engines to return to normal operation. Even with the automatic systems working flawlessly, the plane could not be saved. At 13:09:05, a Mayday signal was transmitted. Thrust loss, no climb. 6 seconds later, all flight signals were terminated. The tragedy was over in less than a minute. A fuel sample was then thoroughly examined. No signs of contamination. No faults in the GE engines. No technical warnings about the Boeing 787. No mechanical failures. The only question, and the only one that remains unanswered, is why both fuel control switches had been turned off at almost the same time, shortly after takeoff. While these switches are protected by a 3-step locking mechanism that requires a clear, intentional force to operate, impact damage makes it impossible to verify the mechanical condition of the switches. Was it an accident, a technical failure, or a deliberate maneuver? No one can say for sure, but the sequence of events, from the flawless takeoff to the fuel failure, the desperate attempt to restart, and finally the fateful crash, has been charted in minute detail. The fateful Air India flight AI171 claimed the lives of 260 people, 241 passengers and crew, and 19 people on the ground, most of them students and staff in a medical college dormitory near Ahmedabad airport. A massive explosion gutted the entire crash site, injuring 37 others, many of them critically. The dormitory was completely destroyed, with material damage estimated at tens of billions of rupees. The Indian Air Accident Investigation Board, along with experts from Airbus and the International Civil Aviation Organization, ICAO, has been called in. The black box has been found. The cockpit voice recorder shows a double warning signal of simultaneous loss of thrust on both engines just seconds after leaving the runway. At this point, the main hypothesis being considered is that fuel contamination or water contamination caused the fuel supply system to suddenly stop working, leading to an almost immediate loss of thrust. However, the final report has not yet been released, and the specific cause is still being analyzed in depth. The incident is a stark reminder of the fragility of the modern aviation system, where even a small deviation in technical inspection or fuel logistics can have catastrophic consequences. It is also a warning bell for airports and airlines around the world to control fuel quality and update emergency response procedures at the most dangerous stage, immediately after takeoff. Thank you for watching today's video on the Black Box Silent channel, where we not only tell stories, but also look back at the painful lessons from aviation accidents to draw the right conclusions for the future. If you find the content useful, please like, share, and subscribe to the channel so you don't miss the next in-depth analysis. We will be back with other stories, where each black box is a message and each small detail can save hundreds of lives. See you in the next video.